means half of that.
17.
How much? 35 half of that. 35 the diameter. Okay, from here
17.5.
to here is 7. It is from here to here it is 17.5. And here also it is same. This is 19 and this is 25. Whatever you have this side, same. This side also it is 19. Okay, and this is 25. Okay, here instead of giving radiuses, we have given the diameter. That's all. We need to divide that accordingly. Now from here to here, this step is 22. Okay, from here this step is 36. Any doubts in this? This is what the drawing which is given. So now, since it is circular in nature, okay, circular in nature, we can go for the protrusion option. Since it is circular in nature, we can go for the protrusion option. And here, what is the hole diameter here? Inside hole we have here. Okay, what is the hole diameter here?
25, sir.
What is the hole diameter? 25. Okay, therefore, here to here, it is how much? Hole 25 means half of that. How much? From here to here.
12.
Half of that, how much? Huh?
12.5.
12.5. So now, I will go for the solid edge. Click on this. Since it is a part drawing, therefore go for the solid part. Click on that. I told you, since it is circular in nature, only we can create this much. Okay, whatever it is shown in 45-degree line, that is hatching, fill lines. Okay, only this much we can create. This much only we can create, and we can make revolve. We can make revolve. So how to do that? Okay, go to revolve protrusion. Since it is circular in nature, select the front plane. Okay, circular and symmetric. Okay, whatever this side we have, okay, this side also we have same thing. Okay, and this side also around 360 degree also it should be same, similar in nature. We are not going to revolve 360 degree. Only we are going to revolve for 180 degree. This is half portion. This is 180 degree. This is half portion. If you join these two, you will get one component. That is bearing housing. Okay, now go to revolve protrusion, select the front plane. After this, go to line option. Go to line option. So now I told you I am going to create this much. Okay, I am going to create only this much. Okay, whatever it is shown here, neglect this hole. Neglect this hole. Only this much only I am going to create. Only this much only I am going to create. Let us see how to create that. Go to line option. So many steps are here? 1, 2. 2 steps are there. 1, 2. Once again, like this, you come. End it. So whatever I shown here, neglecting this hole, only this edged portion only you create it. And here we have a hole here. Don't worry. This 25 mm, that is a 12.5 hole here we have here. 12.5 millimeters space over here. Right. Okay. So now you hole diameter here. This hole. What is the hole diameter? From here. What is the hole diameter?
19, sir. 19.
25. Therefore, radius is how much? From here to
25.
here.
25.
12.5, right? From here to here it is 12.5. Clear? 12.5.
Sir.
Width is very low. This 12.5. Now I told you from here to here it is total distance is 50. The time is 50. Half of that from here to here it is 20. Okay, from here to here, from this plane to this plane it is 25, 25. So whenever this comes, you drag this side, one side, you drag this. Okay, here it is the required shape. Bring it to the required shape. After this, what is the next diameter? What are the dimension which is given? What dimension for the next step?
19, sir. 19 radius.
What are the dimension for the next step? What are the dimension which is given? 38, right?
Yes, sir, 30.
Half of the term from here.
Sir,
Half
19,
of that,
sir.
how much? Half of that is 19.
19.
9. 38. Next to 35. Next step is 35. From here to here 35. 35 by 2 means how much?
17.5, sir.
35 by 2 means 17.5. 17.5. Okay, so half of that. Once again, from the center, from here to here, from this plane, it is 11 from here to here. Once again, from here to here, it is 36 by 2 means 18, and this is 11. And from here to here, totally 25. From here to here, to the end, it is 25 from center. Yes, now go to smart dimension. From here to here, I told you, this is 25. Okay, once again, from here to here, it is 11. From the inside step, okay, this is 11. And up to here, it is how much? 36 by 2 means 18. This is 18.
18, sir.
And this is 25. And this is 25. So here I have divided only this much only I have created. Okay, only this much only I have created, but he has given full dimensions. Diameter is given and full dimensions is given. Only this much from the plane. From this plane I have divided the dimensions. From this plane I have divided the dimensions. Okay, this much only. From here to here it is how much? 11. From here to here it is 36. From this end to the end of this outside. Okay, from here to here 25. The 50 by 2 means 25. Okay, am I audible?
Yes, sir. Yes.
Sir, you are audible.
Yeah. So now this is a revolution, axis of revolution. Now it is going to revolve like this. So now only it is not 80%, it is a 360 degree. Only it is half of that. That is 180 degree. We need to revolve this one. Now just you will get an idea. So now I have selected this plane as the axis of revolution. Go to return option. Go to return option. So now how much degree we need? Here it is not 360. It is half of that 180 degree we need. Okay. Place it, finish it. So now we can see only one side portion we have created. Only one side portion we have created. Only one side portion. This is okay. This side portion. Okay, this side portion only we have created. Only this side portion. So now other portion means just we can mirror image. We can mirror. Go to mirror copy. Select this with respect to this plane. Okay, it will mirror. Finish it. Here. So this is the bearing top housing. Bearing top off or top housing. Okay. So now after this, okay, we have a hole here. What is the hole diameter which is made here? Pi 4 millimeters. Hole diameter is pi 4 millimeters. Next, I will go for the hole. Okay, simple hole. Go to cutout. Select this plane. Go to circle at this center, right? So here it is made at exactly at the center of this one. Now you select the center. So the diameter is how much? Diameter is 4 millimeters. Diameter is 4 millimeters. 4 millimeters. Go to return option. Okay, now which side we have on the plane we have selected this sketch. This side we need, right? We have this side material, not this side. Okay. So now select this side, drag it, and create a hole. Finish it. Are you able to see that hole?
Yes, sir.
Front. Okay, keep it in front. Top. So here, this is what? This is what the drawing which is given here. Are you able to see this now? This is the drawing. See here?
Yes, sir.
See? This is what the drawing which is given. Only I have created this much and I have revolved it. And here we have a hole here. We don't have any material here. See here? We don't have any material here. We have a 50 mm diameter hole. Any doubts in this? Drawing reading is very important.
No, sir.
Yeah. So here bearing, there is a top off. Part number 4 is over. See, part number 5, part number 3 and 4 both are similar except this hole. We have this protrusion part. That's all, nothing else. So what I am doing is, I will save this, apply the material. What is the material? Fe420. What is the material? There is a part number 4 and 3 are brass. Okay, part number 4 and 3 are made of brass. Go to tools, material table, and here this is brass. Apply to model, file, and here file properties, and this is what is the part name? Bearing top off. Bearing top off. Okay. So now in the same fashion, save as, do save as. You no need to create once again. Okay, where I have this one created. File, save as. Bearing top off. Bearing top off. This is completed. Once again, file. Okay, next file properties. Bearing bottom off. You make this as bearing bottom off. Okay, then file, save as. Bearing bottom off. Bottom off. So save this. Save as madkonde. So now this is in bearing bottom off. Okay, now what I am doing is, I will remove this hole. I will remove this because in this case, in this bottom off, we don't have any hole here. Instead of that, we have a protrusion. So what is the diameter of this one? What is the diameter of protrusion?
6, sir.
6. What is the depth here? 5. What is the depth?
5, sir.
5. Then what is the distance from here to here? From here to here, what is the distance? What is the distance from here to here? Within the distance ಎಷ್ಟಿದೆ? Nylin rail, okay, 25. From here to here, 19. Next to, from here to here. From here,
35.
35 half of that. 35 half of that.
17.5.
Yes,
Sir.
17.5 plus 5. 17.5 plus 5. How much totally from here to here? Up to here. From the center up to here, 17.5 plus 5. It is 22.5. So now 22.5. Yeah. So now go to protrusion option. Okay. You select this plane. Select this plane. Go to circle. What is the diameter of that protrusion? 6 millimeters. You give 6 millimeters. Go to return option. Go to return option. Okay, this side we need. Okay, this side we not this side. This side. So what is the calculation? 22. That is 17.5 plus 5. Extra we need
22.5.
22.5. Finish it. So here we have got this extra protrusion. Here. Okay, so here 5 extra protrusion we got it. Okay, now we will know. So here you can observe here. What is this? So here, this we want to remove this. How to remove this? This we don't want here. Only this side only we want. How to remove this? Go to cutout itself. Select this face. Go to circle. From the center, you draw a circle. Okay, which is matching exactly to this one. Go to return option. Okay, if from to this side you move it, finish it off. So here that portion has been removed, but we have this side, bottom side. Okay, that is the extra protrusion is 5 millimeters and diameter is 6 millimeters. So this part has been completed. Any doubts in this? Tools, material table, and this also is brass only. Okay, once again I will show you. So after making save as, right? Save as ಮಾಡ್ಕೊಂಡಾಗ whole delete ಮಾಡಿ. Okay, here go to whole and delete it. Okay, one part na create ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. Same part, that is bearing top of I have created. Once again I have saved same part I have saved as bearing bottom off. In the bearing bottom off, instead of hole we have a protrusion now. So here top off we have a hole. In the bottom off we have a protrusion. I will remove this hole and I will make this protrusion here. So how to do that? How to do that? Go to protrusion here. Go to protrusion. Select this plane because we need in this direction. Okay, in this direction. Therefore, select that part perpendicular to that. Select that. Go to circular circle, and that protrusion diameter is how much? 6 millimeters. Give 6 millimeters. Go to return option. Okay, this side or this side we need. This side or this side? This side, right? Bottom side. So now what is the total length? Yeah, total length is 22.5. Total length is 22.5, correct?
22.5.
Yeah, 22.5. That is 17.5
yes,
plus 5. Okay, 22.5. Press enter and place it. So now we have got this one. After this, we don't want here this extra protrusion from here. I want to remove that. For that, go to cutout. Cutout. Select this surface or this surface. Any surface is okay. This side select ಮಾಡ್ಕೊಳ್ಳಿ or else this side also okay. Okay, select this. Go to circle. From this center, draw a circle exactly which is matching to this one. Inside, that is 25 mm, right? It is 25 millimeters diameter. Exactly, it is matching to this one. Now go to return option. Which side I want to remove it? This side or this side? Left side or right side? It should come.
The left side, sir.
Left side, okay. You drag this. Simply you drag this. Finish it. See now, that extra protrusion we have removed. But this side we should have a protrusion according to the drawing, right? we have this side, bottom side we have this, and we should have that particular point. Any doubts in this? Now apply the material table, branch, apply to model, file. Already say we have done the save as, just save it, save it, save it. Now you can see here, bearing bottom off. In bearing bottom off, we have like this, right? Once again, bearing top off, we have a hole. Are you able to see this now? Both are same parts, similar parts. Only this, instead of hole,
Yes, sir.
there we have a protrusion. But here in this case, we have a save as ಮಾಡ್ಕೋಬೇಕು ಎರಡು ಸರಿ 2 times save as save as bearing top off and bottom off. In that, instead of hole, you remove that hole, you do the protrusion. That's all. Okay. Otherwise, all the dimensions similar to that top off. Any doubts in this? Any doubts?
No, sir.
Now fit this in isometric. Okay, save, close it. After this, come to the next part. That is very important. What is this? Part number 5. What is this part number 5? What's the name?
ಗೊತ್ತಿಲ್ಲ sir.
What is the name of this? In order ಗೊತ್ತಾಗಲ್ಲ, drawing order ಗೊತ್ತಾಗಲ್ಲ ನನಗೆ. Can anyone tell me, other students? What is the name of this?
Sir, cylindrical rod.
It is a bolt actually. Okay, it is a bolt. It is bolt. It is called as a bolt. So here we can see here. This is a bolt. Bolt M10, Fe410, right? Number of bolts is 2. So part number 5 is called as a bolt. This is bolt. Part number 5, bolt. Part number 6 and 7 are nut. Part number 6 is nut M10. Part number 7 is lock nut. There. So now how to construct the bolt, as we can see here. Very important. Go to solid part. So what type of bolt is this? It is a square bolt. Can you see your square symbol here?
Sir, M.
Are you able to see square here?
Yes.
No, square
Yes, sir.
18. Square 18. It is a bolt of square 18. Square headed bolt. It is not hexagon headed bolt. Here. Go to protrusion. Go to protrusion. Select the front plane. What are the square dimensions here? What is square dimension?
18, sir. 18.
18. 18. Okay. 18. Now go to rectangle directly. Width is 18 and also the height is 18, and let us take this is 45 degree. Place it. Go to line option. Draw this diagonal. Go to move option. Take the center and place it exactly to this center of the plane. So now remove this. I don't want. Remove this. So now this square is how much? Square is drawn to the corner position, not to the heads. To the corner position, not to the heads position. Okay, because I need to chamfer. For that reason, I have drawn this to the corner position. Later, I need to do the chamfering of the bolt. However, we have done now. In the same way, you have to do your chamfering. That's why I have constructed this sketch to the corner position. Yeah. Okay, this is a corner position, not to the heads position. See, I have not constructed this drawing to heads position. Head positions will be like this. 18, 18, and angle is 0. Heads position like this, right? So I have constructed here corner position, heads position. What is the position of this? What is the position of this one?
Sir, corner, sir.
Okay, this position is corner position and this position is edge position. That's the thing. Okay. So I need only edge position here. So now what is the thickness here? How much amount we need to extrude here? How much? What is the thickness?
Sir, 6.5.
6.5. Go.
6.5, sir.
Go to return option. Select symmetric here. There is second option symmetric. Give 6.5 millimeters. Give 6.5 millimeters. Then finish it. Are you able to see this now? Front. Top. Okay. 6.5 means 6.5 symmetric means this side 6.5 by 2, 6.5 by 2. That is 3.325, 3.25 this side, both the side. If you take symmetric, understood what is symmetric? Symmetric means this side 6.5 by 2 and this side 6.5 by 2. That is the meaning. That is 3.25 and this side 3.25. This side 3.25. That is the meaning. Any doubts? So this is a bolt, and later we can do the chamfering, don't worry. And what about the bolt length, total bolt length? What about this bolt length? What about the bolt length? What about the others? What is the bolt length?
70.
What is the diameter? M10. M10 means 10 mm diameter.
Sir,
Now go to
101, sir. 101 is.
no from here. Okay, from here. From here it is 75. Okay, from this face it is 75, and its diameter is 10. M10 means
Yes, sir. 70.
M10 means 10 millimeters. You need to take. Go to protrusion option. Select this face. Select any face, not a problem. Okay, you can select either this face or this face, any face. Go to protrusion. Select this face. Circle. What is the diameter of that? M10, right? M10 means 10 millimeters. M10 means what is the diameter you need to give? 10 millimeters. M15 means 15 millimeters. M12 means 12 millimeters, like that. Go to return option. Now what is the length of the bolt? 70. What is the length of the bolt? 75. Length of the bolt?
75, sir.
Length of the bolt is 75. So now, here he has done some threading here. Are you able to see threading? What is the length of the thread? What is the length of the thread?
26, sir.
26. Okay. What is the thread parameter? M10.
M10, sir.
M10. Okay. So now go to which option now? Option 1. Go to below the hole. We have a thread option. Straight thread we need. Select the cylinder. From where it need to start here? From this end. Okay, so now what is the length of this? 26, correct? What is the length of the thread? M10 thread? 26. Here you select a finite value, and here you select 26, and here it is M10. So length of the thread is 26. Select finite value, length of the thread is 26, and it is M10. From this end it will make the thread to the length of 26 millimeters. Finish it. But in this case, in this V, it will show full thread. Okay, it will show full thread. It will show full thread. Don't worry. Okay, only how much mm we have made here thread? What is the length we have taken? 26 only. Format, view, textures. So it will show full thread. Don't worry. Okay, that is actually one of the enhancement in this software has to be done. Even though if you give 26 mm length, it will take full. It will show full mm length. Okay, full thread length. Don't worry. Okay, leave it. Okay, so we have made 26 millimeters. That is thread length. How much? 26 from this end. So now we need to do the chamfering here. Are you able to see here? Are you able to see chamfering he has done? Can you see? Yeah, he has done chamfering. So, okay, how to do that chamfering? That is very important here.
Yes, sir.
Okay. So now go to here. One more. We are using revolve cutout. Revolve protrusion alla. Revolve cutout cut ಮಾಡೋದಕ್ಕೆ 360 degree we are using revolve cutout. Okay, to remove the material around 360 degree. Okay, to add the material we are using revolve protrusion. To remove the material in a circular way, okay, we are using revolve cutout. Now select this plane, select the mid plane. Either you can select this plane or this plane, any plane. Okay, select this plane. Okay, select this plane. Now, how to do the chamfering of this bolt head? This is a bolt head actually. This is a bolt head. Okay, this is completely bolted, and this is a shank of the bolt, and this is a bolt head. So we need to do the chamfering at the bolt head. How to do that? Can you tell me how to do that? What is the procedure we have done in the theory? So what is the chamfer of the bolt head? What is the chamfer angle of the bolt head? What is the chamfer angle?
60 degree, sir. 60 degree.
Okay, with respect to this one, it is
60 degree, sir.
With respect to axis, it is 30 degree. With respect to axis, it is 30 degree. Okay. With respect to axis, 30 degree. Here you can check this. Here it is with respect to horizontal 60 degree. With respect to vertical, it is how much? It is how much? 30 degree. Are you getting what I am telling? With respect to vertical,
60, sir.
30. With respect to horizontal, 60. Yeah.
Yes, sir.
Now, after this, what the next step we have done to remove the material? Go to line option.
Sir, same, sir. A point in the end varaku join ಮಾಡಬೇಕು.
Okay. From this mid of this face, you draw the line. You draw the line. Remove this. So this is the center what we require. So now go to arc by center point. Go to arc by center point. Arc by center point. Take this as center up to here as radius. You draw an arc. You draw an arc. Like this. Okay. So after this, I need only this much. Only this much I need. Only this portion I need. Only this portion. So now after obtaining this arc, okay, now what I am doing is from this end, I am going to draw a line. Once again, this side also I am going to draw. Now go to trim option, trim this, trim this, trim this also, and this one. Okay, and even this also I don't want. You remove this also. You remove this also. Trim this or else select it and delete it. Are you able to see this one? What we need here? Yeah, this is what we require. Now go to axis. Select axis of revolution. Select this center plane. Go to return option. So the revolve which we need, what the amount of angle? 360 degree. Okay, finish it. 360 degree. 360 degree. Now are you able to see this chamfering now? Are you able to see the chamfering?
Yes.
Once again, I will show you this. Once again, I will show you. Okay. ಇಲ್ಲ ಇದೆಲ್ಲ ಮಾಡೋದು ಬೇಕಾಗಿಲ್ಲ ಅಂತಂದ್ರೆ you just you can also simple way, in the simple way you can also do it. Go to real cutout, select the plane, mid plane. Okay, mid plane means this is a plane which I have selected. Okay, this is a plane, this plane I have selected. Okay, now what is the procedure we need to do? From here you draw a line. What's the angle? Respect to vertical. Respect to vertical. 30 degree. 30 degree. Now from the center of this face, draw a line. Trim this axis line. Now go to arc center point. Take this and this as center. Draw an arc. Draw an arc. After this, go to line option. From here you draw a line, and here also you draw a line. Only this much I need. Go to trim option. You trim this also, this, and this one, everything. This also. You remove it. So now we can join this end to this end. Join the line. And here I told you this is how much degree I am getting. We are getting 18 degree. Okay. Remove this. You can see here this length is 2.02 and this is 6.3. This is 6.336. If you want directly, you can remember, or else you have to do like this. You have to do like this. So this is what this is how we need to do the chamfering. Any doubts in this? Same procedure you have done, right? Same procedure we have done. Yeah.
Yes, sir.
Okay, so now from here you draw a line up to this one. What the angle between? How much it is there? 30, 18.
18, sir.
No need to. Okay, mark that. Leave it. Go to trim. Trim this one and this one. Only this much portion we need to draw. Okay. Go to return option. Select the revolve axis. Select this axis. Go to return option. So now we need 360 degree. Select this. Finish it. Select this and finish it. Are you able to see that chamfering?
Yes, sir.
Now you can see, right? Okay, you can see that. In this case, you are going to see like this. Like this. This is what it is shown here. This is what it is shown here. Are you able to see this now? This is what they have shown in this drawing. Yeah.
Yes, sir.
It's a view across this one. Face, flat face, it is shown. Not view across corners like this. These are two-face view. This face and this face, two face we can see. These are two face view. What he has shown is single face view. There is a view across points like this he has shown. Okay. Any doubts in this? This completes your bolt, M10 bolt. Okay, go to tools.
Okay.
Material table. Material table. What is the name of this? M10 bolt. Sorry, material is what is the material it is made of? Fe410. All are Fe410 extra. Remaining parts are all Fe410. That is iron grade. Iron grade. Okay. Which are made of iron grade. ಕೊಡ್ಬೋದು ನೀವು ಕೊಡಿ iron Fe410 or mild steel like that you can give it. Fe410. Right model. You remember illa anta yavado one material kodi, don't worry. Except brass and aluminum, you can give anything. Okay, except brass and aluminum, because those are very soft materials which we cannot give here. Except those, we can give any material, not a problem. Okay, so now file properties, M10 bolt. Save this. File. Copy this one. File, save as. What's the part name? M10 bolt. Save this. Close it. Let's go to next part. Which is the next part? Hexagonal.
Sir, hexagonal
Thread. Nut algana idu.
Hexagonal bolt net sir.
Nut ko bolt ko difference gothilla. Bolt, this is a bolt, right? And this is a nut. And what is the thickness of this nut? 8
millimeters.
Okay, what is the bolt diameter here? Shank diameter? What is the shank diameter?
10 sir.
10. Therefore, what should be the sides of the hexagon? What should be the sides of the hexagon? Either sides of the hexagon is given here. The sides of the hexagon is given. Sides of the hexagon is not given. Therefore, sides of the hexagon is equal to this shank diameter. Shank diameter is 10. Therefore, size of the hexagon is equal to how much? 10 millimeters. Okay, size of the hexagon is equal to shank diameter. Now, let me construct hexagon. First, this thickness of this hexagon nut we need to construct. Later, we can do the chamfering and all. Go to protrusion. Select the front plane. I will select top plane. Because I am going to construct like this. Okay. Now you can select any plane, not a problem, don't worry. Go to line option. So what are the sides of the hexagon which you need to construct here? Sides is equal to shank diameter. How much is that?
10 sir, 10 millimeters.
10, and angle is 0. Next 10, angle is 60. Next 10, angle is
120.
120. Next 10, angle is 180. Next 10, angle is 240. Later you join this.
70.
Later you join this. You can check this. This diameter is equal to 10. The diameter of this particular shank is 10 millimeters. Therefore, sides of the hexagon is equal to 10 millimeters. Okay. Okay, it will not give you. Okay, this is where you are going to confuse. Sir, it is not given. Sides is not given. Like that, you are asking the question. Don't ask the question like that. Okay, this diameter is equal to this size of the exam is equal to shank diameter in case of nuts. Okay, so now we should draw hexagon of sides 10 millimeters, all sides 10 millimeters. Or else here we have tools, applications. So here applications, we have macros, run macros. Okay, run macros, and here browse this particular folder. Okay, local disk, program files, solid edge, custom, n-side polygon, bin. In that bin, okay, we are going to get this n-side polygon. Click on this, open here. One window will open. Okay, select this radius from flat. Select the third option, flat length. Length is how much? What we need is 10 millimeters. How many number of sides are there? 6. Place it outside.
6.
It will come. Yeah. Place it outside. Directly you can create it. So the application, macros, run macros. And here browse this bin folder. In there is the C. Where you are going to install this program. There is a software. That in that particular folder, particular file is available. Program files, solid edge, custom, n-side polygon. In that bin, we are going to get this n-side polygon option. N-side polygon. Click on this, open it. Dialog box will open. Select the third option. There is a flat length, and what is the length of the sides is equal to 10 millimeters, and number of sides is equal to how much? 6 millimeters for the hexagon. Click on this. There is outside the box, you click on this, like this, it will come. So yeah, are you able to see this now? So like this, you are going to get
Yes,
particular, this one. Delete it. I need one of the drawing. But I need this one in corner position, okay? But I need this one in corner position. Go to line option, draw one diagonal to get the midpoint here. Now go to move option. You pick the center. Are you able to see the center here? Center symbol. Okay, one symbol will appear. Okay, just move the cursor here. One symbol will appear. There is a center symbol, center of this particular line. So now place the center exactly in the center of this one, center of the planes. Now I don't want this line. After placing it, you remove it. Okay. Go to return option. You select the symmetric here, symmetric option. Both the side from the plane, it will extrude equally. Equally, it will extrude. What is the total length here? Total length is length of extrusion how much? 8 millimeters. Give 8 millimeters, that's all. Whatever you have, you just give it. That is 4 millimeter this side, 4 millimeter this side. Both sides equally it will extend. Finish it. So now this is hexagonal this thing protrusion we have created for the head. For the head. So now here he has made one hole, right? For the hole M10, right? Shall I go for the cutout or shall I go for the hole option here? We have a thread here. We have a thread.
Hole option.
Hole option. Okay, go to hole option. Go to hole option. Not the cutout option. Go to hole option. Select this face. And here, click on this hole option. And here, a thread. It is a simple, we don't want any V bottom here. And here, you select throughout the next. It will extend up to next. And this is M10 only, right? What is the thread? M10,
sir.
M10. Okay, you select M10 here, and here up to throw next. You select this. Click on OK. Place it on the center. Go to return option. This side or this side? This side we need. Place it. Finish it off. Are you able to see this? There's a thread inside the thread. Okay, hole. That is we have made both parallel. That is hole as well as threading. Both we have done. at a time. Clear? That green color represents what? Green color represents what? Format,
Cool.
view, texture. Are you able to see the thread? Are you able to see the thread?
Yes, sir.
That, yeah, that green color represents a thread. Format, view. I don't want that to show that thread. I'll remove this, uncheck this. Okay. That green color is a thread only. Don't worry. So now we need to do the chamfering of this one. How to do the chamfering for this both the face? We need to do the chamfering, correct? To both the side, we need to do the chamfering. Both the side we need, right? Both the side as right? This side as well as this side. Both the side has done the chamfering, right? How to do the chamfering for this
Yes,
bolt?
sir. On both sides.
For the nut. How to do the chamfering for the nut? Okay, now go to revolve cutout to remove the material in a 360 degree. Go to revolve cutout. Now select a plane passing through the corners. Select a plane passing through the corners. Which one is the plane passing through the corners here? Which one is the plane passing through the corner here? Whether this plane or this plane? Passing through the corners.
Vertical plane.
Whether this is the plane?
No, sir. Vertical plane. Sir.
This plane, right? Front plane. What is the name of this? This is a plane which is passing through the corners. Are you able to see this now? The plane passing through the corners is
Yes.
front plane. The plane passing through the corners is front plane. So now go to revolve revolve cutout, select the front plane. So now I have taken three face view for this particular. Are you able to see this? How many faces here? 1, 2, 3. 3 faces, right?
Yes,
3 faces we can see here. 3 face view always you select. Okay, that is if you select the plane passing through the corners, you will get 3 face view. Always select the 3 face view. And here, I told you, in the same fashion, however, we have done for this particular chamfering. In case of 2D drawings, in the same fashion you have to do here. This is how much? 30 degree. So the mid of this, you draw a vertical line. Okay, remove this. So now go to arc by center point. From the center up to here as a radius. Up to here as a radius. Okay. Draw an arc. Draw an arc. After this, go to line option. Select this also. Select this. Draw the vertical as well as horizontal line. You draw this. So now, go to trim option. Trim this one. This also. Okay, I don't want this one also, and this also. Okay. So now go to angle between. Go to line option. Draw a line from up to here. Okay, from this end to this end, you draw this. Go to angle between. You draw this line at an angle of 30 degree. 30 degree. Okay, so what is the amount? 30 degree, because chamfering angle is how much? 30 degree. Chamfering angle is 30 degree. You remove this. Chamfering angle is 30 degree. Once again I will explain. Okay, after this, go to trim option. Go to trim option. To trim this one as well as this one. Okay, and as well as this also. Trim this. So now go to line option. Go to line option. Draw a line from end of this to the end of this one. Draw a line. Okay. So after this, go to angle between, select these two. This is how much? 30 degree. This is 30 degree. Remove this. So this is 30 degree. Extend this one. Extend this up to next. Okay. Trim this. If you want, you can check this. What is the dimension of this one? 1.4 and 2.5. How much? 1.5 and 2.5. So now instead of doing all these things, I have a simple way of putting on him. Okay, I will tell you simple way. Go to revolve protrusion, revolve cutout. Select the plane passing through the corners, that is front plane. Now just simply you construct a triangle from this point. You simply construct this. After constructing, go to angle between. So this should be a much? 30 degree. Any doubts on this? This is very simple, right? This is very simple, right? So this is 1.44 and this is 2.5. Okay, go to return option. Before going to return, we need to select. What we need to select? So your revolve PHR must be an axis of revolution. Now go to axis of revolution, select this. Go to return option. Go to return option. What is the angle? 360 degree. Finish it off. Whether we need one side or both the side. Both sides we need. So for that, what I am doing is, go to revolve cutout. Go to revolve cutout once again. So in the same shot, we can complete it. Not a problem. Okay. Select the front plane. Zoom it. So now go to line option. Start from the center to the end. Draw a line. By using line, you draw a triangle. Go to angle between. Draw a give the angle, which is chamfer angle is how much? 30 degree. Chamfer angle is 30 degree. Okay, so after giving this side also you mirror it. Go to mirror option here. You have a mirror option. Select this sketch. With respect to this mid plane, click on this, then right click. Once again, I will show you how to mirror this. Go to which option? Mirror option. Select this one. With respect to this plane, you mirror it. Then go to return option. So we need to select the axis of revolution now. Click on this axis of revolution. Select this axis, center axis. Go to return option. So now it is 360 degree. Finish it off. Whether we got both the side. Whether we got both the side?
Yes, sir.
Okay. So here, one thing I will tell you. While constructing itself, okay, you draw a sketch both the side like this. While constructing itself, you draw a sketch both the side, or else. Okay, what I am doing is I will construct only one side. Okay, and I will come to return and finish it. Only one side I have done. Next, this PHR itself we can mirror it. This PHR itself, this side, after constructing also we can mirror it. And here we have an option called as mirror copy PHR or mirror copy. Both are okay. Mirror copy PHR. You select this. Which one? This cutout. Correct? This cutout. With respect to this one, with respect to,
Yes, sir.
take this smart dimension, click on this, with respect
Vertical.
to, with respect to, front plane, you mirror it, yeah, finish it off.
Vertical, sir.
So, both the side we have got this. We can do in both the way. While creating drawing itself, sketch itself, we can do both the side, or else one side you create it, later we can do the mirror feature. Written, we can do the mirror copy feature. So class is that mirror copy feature. Okay. So you can see if you select this, you can mirror copy feature. You can do it. You can mirror that particular feature with respect to midplane. Any doubts in this construction of this particular volt? Sorry, nut.
No, sir.
This is M10 nut. This is M10
No,
nut.
sir. No, sir.
Tools. Okay. What is the material? FA 410. File to model. File.
FP410.
File properties. And here this is M10. M10 nut. M10 nut. I will copy this one. File. Save as. And this is M10 nut. Save this. M10 nut. Let's come to the next part. Part number 7. So here it is similar to that only, but what is the thickness here? What is the thickness here? What about in this
5, sir.
here 8 and here
Here 8, sir.
5?
5, sir.
Okay, so now what I am doing is I will save this itself. I will save this as that is lock nut. I will save as okay. I will make this save as and I will save as lock nut. This is a lock nut actually. Okay, this is a lock nut. So now I will save this file and here also file properties. I will give this as a lock nut. Lock nut. Okay, okay. Say okay. Okay, clear? Okay, now I am in lock nut. So now we need to do the modification. Where we need to do the modification here? What is the difference between these two? What is the difference between these two? What difference is there? Can you tell me what is the difference between these two? Lock nut and M10 nut. This is 8 mm thickness.
Sir, diameter.
So diameter is 10, shank diameter is 10 only. Okay. What is the thickness? Thickness
Sir,
is
length
8 millimeters. And here,
sir.
thickness is how much?
ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 8 millimeter, ಇಲ್ಲಿಗೆ ಅಲ್ಲಿಗೆ 5 millimeter ಇದೆ ಸರ್.
It is not length, it is the thickness of the nut. Thickness of the nut is 5 millimeters. Yeah. So here what we have is 8 millimeters. So that we need to modify.
Okay, sir.
How to modify? Protrusion. Click on this, right click. Then edit. If you want to change the thickness, edit definition. If you want to change the profile, sketch. If you want to edit the sketch, edit profile. I want to change the thickness here. Go to edit definition. Click on this extend step. Second option. So now, how much we need to change here? Instead of 8, it is 5. 5. Then finish it off. Then finish it off. Are you able to see this now? Lock nut. What is the difference here? Only thickness is thickness is only, in this case, it is
Thickness is
5
changed.
millimeters in the lock nut. It was 8 millimeters in the M10 nut. Okay, M10 nut. Here, M10 nut, it is M10 nut. ಏನು ಫೈಲ್ ಎಲ್ಲರೂನಾ ಹಾಂ
ಸರ್ ಸರ್
ಟೆಲ್ ಮಿ ಜಸ್ಟ್ ಎ ಮಿನಿಟ್, ನಾನು ಇಲ್ಲೇನೋ ಮಾತಾಡ್ತಾ ಇದ್ದೆ. One minute. Okay. So here, this is part number 6 is simply a nut. It is what is the part number 6? Nut. It is having 8 millimeters thickness. Part number 7, it is lock nut. It is having 5 millimeters thickness. That is the only difference. This is also M10. This is also M10. Any doubts in this? No need to create once again.
No, sir.
In save as, make that file name as lock nut and only change the thickness. Instead of 8, give the thickness as 5 millimeters. That is the only change will come. After this, okay, so now we have saved this as lock nut. Fit this, keep this in isometric, fit this, save, then close it. Go to solid part once again. What is the next, last part? What is the last part? What is the name of this? Shaft. Name of this is shaft. What is the diameter of this one? What is the diameter? What is the diameter? What is the diameter? Hello? What is the diameter of the shaft?
Sir, 25, sir.
What is the length of the shaft? What is the length of the shaft? Whether it is given, length of the shaft is given.
25, sir.
Diameter is 25. Okay, diameter is 25.
No, sir.
Length is, you can select length of the shaft as more than this 36. More than 36. Or else you select more than this, more than 50. So this bearing housing length is how much? 50 is there, right? This bearing housing length is 50 is there. More than 50 you select the length. Go to protrusion option. Select the front plane. Go to circle. And shaft diameter is how much? Shaft diameter is 25.
25, sir.
25. Give 25 millimeters. Go to return option. Okay. 25. Go to return option. I told you what is the length I should give you. What is the length I should give? In symmetric,
more than 50.
Symmetric extent, you give more than 50, that is 60 or 70. I will give 70 or finish it. What is the material it is made of? I think Fe410 only, right? Fe410. Its material is tools, material table, Fe410. Apply to model. Fit this file properties, summary, shaft. What is the name of this? Shaft. Say OK. Isometric, then fit this, save. So this is a shaft. This is a shaft. Shaft. Save this. So many parts are there totally? Totally 8 parts are there, right? Out of 8 parts, net M10 is 2 numbers. M10 is 2 numbers. M10 bolt is 2 numbers. Lock nut is 2 numbers. Shaft is 1 number. And bearing top of 1 number, bearing bottom of 1 number, cap is 1 number, and body is 1 number. Whether we have it or not, we check it. One, there is body. Next, bearing there is a cap. Second part, third, fourth, 5, 6, 7, 8. Totally 8 parts we have completed according to the given. Let us take this as 2D drawings. 2D drawings. One, two, three, four, 5, 6, 7, 8. How many parts are there? 8. So all the parts have been completed for the Plummer block assembly. Okay, now close this. Okay, now what is the option we need to go for the assembly? There are 5 options are here, right? What is the option? Go to assembly. Let us click on this assembly. Now where I have saved here CAMD, and in this assembly drawings, I'm saying in the Plummer block, yeah, I have all the drawings here. Okay, browse the folder. So here, in case if you don't have this, how to get this tool? In this, click on this edge bar. In this, browse the path. Browse the path library where I have saved. Okay, in D drive, in the name of MJAR CAMD, I have saved this. Click on this once again assembly drawings in this Plummer block. Okay, in this I have saved all these. So now which one is the first part we need to move here? We need to call. Which one is the first part? Which one is the first part?
Body, sir.
ನಮಗೆಲ್ಲ ಅಸೆಂಬಲ್ ಮಾಡೋದಕ್ಕೆ ಏನು ಬೇಕಪ್ಪ?
Body, sir.
Body, right? Body. So now drag this inside, the body will come. Next, after this, bearing bottom off. Okay, we need bearing bottom off. We need bearing bottom off. Here, this is what bearing bottom off. Part number 3, which we have a protrusion here, not a hole. Okay. So now we need to call bearing bottom off. So now, however the position we need to rotate it. Okay, and simply you drag this inside. Okay. So now this should be coaxial with respect to this one. This should be coaxial with respect to this one. Once again, this protrusion is there, no? This should be coaxial with respect to this hole. Any doubts in this assembly? So let's show once again.
Yes, sir. Sure, sir.
Yeah. Okay, so once again, go to part library. First part is body, drag it inside. Next part is bearing bottom of, bottom of. Okay, if you want, you can rotate this to required position. Then drag it inside. So first we need to coaxial this hole with respect to this one. Okay, we have done coaxial. Next, this protrusion is there, no? This protrusion center should coaxial with respect to, zoom it, respect to this hole,
That hole, sir.
with respect to that hole. Now it has been assembled. Any doubts in this? Okay. Now
No, sir.
next, bearing bottom is off is over. Next, which one is this? Bearing top off. Okay, bearing top off. Upper part. Okay, very top off. Now drag this inside.
Upper, sir.
This should be coaxial with respect to this one. This should be coaxial with respect to this one. Okay. After this, zoom this, and this should be made with respect to this surface should be made with respect to this one, and this surface should be made with respect to this surface. See here? That's completely assembled. Any doubts here? I'll show you once again this bearing top off. Keep this isometric.
No, sir.
Bearing top off. You drag this inside. Okay. This should be coaxial with respect to this one. Okay. Now this surface should mate with respect to this surface. After this face, okay, this face should mate with respect to this one. So now it has moved inside. Exactly, it has fit inside that. So this hole is for lubrication purpose. Okay, here shaft will come here. Okay, shaft will come inside. Okay, this is for the lubrication purpose. Now, also what I am doing is I will hold. Okay, I will select all these reference planes. Okay, and I will hide this because those are making me very confusion. So whenever you want, you can show this. If you want, you can get back. Let us make this as hide. Shall I hide this? Okay, here in this assembly path part, you click on this, hide this. I don't want any planes here. Planes to see. Okay, after this part library, come to the cap. Come to the cap now. Keep this in isometric. Arjun sir, ನಾವೆಲ್ಲ ಹೋಗ್ಬೇಕಿತ್ತ ಅಲ್ಲಿಗೆ?
Sir.
Okay. Okay, you drag this inside, drag the cap inside. Okay, so now how to assemble this part? This part number, there's a part name is called as a cap. How to assemble this? So now this should be coaxial with respect to this hole. Move this, drag this. Once again, this hole should be coaxial with respect to this one. Now see exactly it is coaxial, correct? So now this bottom face is should mate, this bottom face of
Yes,
that
sir.
particular face should mate with respect to this one. Keep this in front.
Okay.
Any overlapping happens, we can see. Okay. So actually that should not go like that. So here it is overlapping here. Keep this in front. Check whether any overlapping happens or not. Keep this in front. Okay. Here, I will remove this font. Once again, I will assemble this because it may be overlapping. So it should not come here. See here, the top of all one bit is this part of this part has come inside this okay. Remove this. But we have to see that. Okay. Now. Yes, 19. And here we should leave a gap here. Notice here, should not fit exactly or onto this particular face. Okay, this face should not. Okay, bottom of this cap should not sit on this face because there's some gap is there, some 6 mm gap is there. So like that, we need to provide a gap here. Okay. Okay, now keep this in isometric view. Now bring the cap inside. Now we can make this this with respect to this coaxial. We can make this, or else this hole and this hole and this hole and this hole we can make coaxial. This hole should be coaxial with respect to this one. Drag this upward direction. Right click once again. This one should be coaxial with respect to this one. Now this is coaxial. Now what I am doing is this surface should mate with respect to this surface. You give like that. Are you able to see this now? Now this is not overlapping. Yeah. Don't give that bottom surface to that. Once again I will show you. Once again I will show you. Okay. Keep in isometric. Bring the part that is cut as a cap. So now this hole should coincide with respect to this one. Move this upward direction. Then right click. Once again, this hole should coincide with respect to this one. Now this exactly coincides. Now this bottom surface of this one should mate with respect to which one? Respect to this one. Yeah.
That
so now it has been completely. Now this is assembled. After this, what is the next thing which we need to do? Bring the bolt. Bring the bolt. Keep this in isometric. Fit this. Bring the bolt. Bring the bolt. Rotate it in this direction, upward direction. Okay, in this direction. Drag this. So now we need to insert from the bottom. We need to insert this bolt from the bottom. How to do that? This is very important. This is coaxial with respect to this one. So now this surface should parallelly mate with respect to this one. Okay, it will rotate. Once again, this bottom surface should mate with respect to this surface. Are you able to see this now? It has gone inside. Shall I show once again? Okay.
No, sir, it's clear.
Yeah, I will show once again. Still, I will show once again. Isometric. Fit this. Okay, you rotate this to the required position. Then drag it inside. This center is a bolt shank center should coincide with respect to that whole center. So now we need to make this parallel. That is, this surface should parallel to this surface. It will rotate. Now this one should mate with respect to this face. It will go inside. So yeah, are you able to see this? Yeah. Any doubts in this? Okay, now you need to bring the
Sir, fit ಆಗಿಲ್ಲ sir. ಥ್ರೆಡ್ ಅಂದ್ರೆ ಸರ್ ನೆಟ್ ಹಾಕಕ್ಕೆ ಥ್ರೆಡ್ ಬಂದಿಲ್ಲಲ್ಲ ಸರ್.
See, thread, don't worry about the thread, okay? Don't worry about the thread, okay? That represents thread only.
Okay.
Yeah, green color represents thread only, okay? Don't worry about it. Remove this texture, then let it be like that, okay? And that doesn't look nice. That's why I'm turning off this. I'm turning off this feature, okay? This green color represents thread only. Don't worry about it. Yeah. Next, bring the lock nut. Bring the lock nut. Now, this should be coincide with respect to this one. It should be coincide with respect to this one. Once again, bottom of this should exactly match with respect to this one. Okay. After this flat surface should be parallel to this one. Yeah. Now are you able to see this now? Once again, I will show you to assemble the nut. Click on this part library, lock nut. This center, there's a hole, should coincide with respect to this bolt center. Bolt center, zoom it. This flat surface should be parallel to this flat surface. It will rotate. Once again, this bottom surface should sit exactly on this top surface of this body. Now it will sit. Any doubts in this? Next, bring the nut. Bring the nut. Lock nut is over. Next, nut. Bring the nut. Call this inside. Now, the center should coincide exactly with respect to this one. Drag this. Right click. Then, this surface, zoom it. This bottom surface should sit exactly over this one. And this surface should parallel to this surface. It will rotate. See? Any doubts in this?
No, sir.
Okay, so now this side we can mirror it. Very simple. Instead of assemble, we can mirror it. That's all. So here we have a mirror option, mirror components. What are all the components we need to mirror here? Any components mirror ಮಾಡಬೇಕಿಲ್ಲಿ?
Sir, net ಮತ್ತೆ ಇದು sir.
Yeah, show this reference frames. So now I need to go for the mirror components. Now click on a reference frame from where we need to mirror is this one. Now select this lock nut and this nut as well as bolt. All the three. I have selected all the three. Correct? You can select here in this assembly tree, assembly pathfinder. You can select this. Next, click on this right mark. Okay. Finish it. Are you able to see this now? Are you able to see? What about the remaining students? Start to me.
Yes, sir.
Chandan, where are you? Chandan, are you there? You can see in the front view, you can see like this. In top view, you can see like this. Top view, you can see like this. Next, last part, which is the last part which you need to assemble? Which one? One part we left. Which is that part?
Shaft, sir.
Yes, shaft you need to assemble. Call this inside. Then this should coincide with respect to this one. Keep this in top view. And just move this to convenient position. That's all. Finish it. So now isometric, fit this one. So this complete assembly has been made. All the parts which are made. Here, so here 2 lug nuts will come, 2 M10 nuts will come, 2 bolts will come. That's what he has given in this bill of material. Lug nut, how many are there? 2. Next nut M10, 2 are there. Bolt M10, 2 are there. Okay, so these are parts which are having 2 numbers. All remaining 1 only. Body 1, cap 1, bearing bottom of 1, bearing top of 1, shaft is 1. Any doubts on this? Up here. Okay, now I will go for the creating drawing. Okay, first before going to that, save this. Save as in this assembly. There's a plumber block. Plumber block assembly. Save this. Next, I am going for the file in this create drawing. Click on create drawing. Okay, click on next, and here is select front is the main reference for us. Next, so you have selected already front, top you select, and isometric you select. Finish it, then place it here. So what are the sheet we need here? Sheet setup. A4 size. Select.
A4, sir.
Uncheck here. Save defaults. Okay. Now bring this inside. This also drag this inside. Drag this inside also. Okay. I think this is not possible inside here. You can change the scale here. Show scale 1:2. Yeah. So now update, right click here. Click on this gray shaded gray scale with visible edges. Then update here. Update views. Fill update. Okay, after this, And here we don't want any these hidden lines here. If you don't want any hidden lines, click on properties, and here display hidden lines. If you hidden edge style, remove this, then no hidden lines will come. See here, no hidden lines will come. Right click here once again. Properties, if you want hidden lines, then check this. Once again, okay, it will come. So now we need to show this section, right? See, what we need to show? Section we need to show. Okay, section we need to show. For that, go to first construct a section plane, cutting plane. For that, go to cutting plane. Where you need to show the cutting plane, on top view or front view? On top view. On top view, click on this top view. So now full sectional front view I need. Start from this here, from the center, end it here, then finish it. Which side we need here? Section this side or this side? Okay, this side. This means this portion I am going to remove here. Yes, this portion I am going to remove. Only this portion I am going to see. Only this portion. Here. Next, go to sectional view. Next, click on cutting plane. Click on this plane AA. Then move this view to match this particular this one. Okay, this bottom this one is exactly should sit exactly to that. Okay. Next, go to select. Now we can we have created the sectional view. Now for the shaft bolts nuts, we should not create any this one section. For that reason, if you want, you can remove this hatching for one of the shaft, bolts, nuts and all. We should not show the hatching. That is, section should not be shown for the fasteners, screws, shafts, like that. Only main parts only we need to show the section. For that reason, go to drawing in view, remove this hatching, and here also remove this hatching which you don't want, and for shaft also remove this, and for the nut and for nut also remove this. Others bit range ತೊಂದರೆ ಇಲ್ಲ. Okay, let it be like that only, not a problem. But usually in a practical applications we are not showing section view for the fasteners. Now go to return option. Fit this. Now your drawing is ready for printing. Okay, now what about a part list? Click on this, and here we have a part list. Click on this. Okay, if you want bullets, you can click on this one, not a problem. I want this table. Here, entire the table, whatever you have created has appeared. So now your table properties, click on this. Here, I don't want this document number column here. I don't want this document number column. Click on this column, and I don't want document number. Or remove it. Okay. Now fit this. Once again, I will show you this. Once again, I will show you how to construct a bill of material. That is not actually necessary, but still I am showing. Okay. Part list. Click on the drawing view. Click on this one. I don't want bullet means you remove it. Only I need only the table means you select this one, then finish it. It will come. Then finish it. It will come. Then table properties. I don't want document. Go to click on this column tab, and here I don't want document number. Remove this. Okay. Variable says body is one number. Okay. And here we can see body is one number, bearing of one number, bearing top of one number, cap is one number, M10 board two numbers, local what is that? Nut. M10 nut is lock nut. Lock nut is two numbers. Okay. M10 nut is two numbers. Shaft one number. So like it. We need to create a bill of material. This is called as a table. This table is called as bill of material. Any doubts in this? Now save this. This as the drawing. Okay, 2D drawing. Plummer block. Plummer block. Save this.